All right. Bell ringer on the board. Let's go. Anybody need more time? Okay. You got 30 seconds. All right, time. Let me switch here. Anything difficult about that? You'll see a lot of those when you take senior guys. All right, good job. All right, put everything away except for your guided notes that I gave you. $49.92. guys have. I think the reason it's one of your favorites is because you actually get to launch stuff at somebody. So, you know, rather than just throw the ping pong ball at somebody, you get to actually shoot it out of something.
Some of us did enough ping pong balls.
What's that?
Some of us did enough ping pong balls for that.
So we talked about launch angles and stuff. I kind of changed the assignment a little bit. You guys will see it on the printout. We used to vary the launch speed and the launch angle, but now we're just going to go with changing the launch angle at variable degrees. So it's a code you guys will have to think about. The first thing that I want you guys to do once we go through the PowerPoint is I'll put you in your teams of 2 or 3, and I want detailed drawings. We talked about this. Detailed drawings of what you plan on building. The main thing is, what's the first principle that I talked to you guys about in the first couple days of class?
The design process.
Okay, the design process. But what was a key to success in engineering? Remember the KISS principle?
Keep it simple.
Keep it simple. You guys see this thing, okay? Do you see any simplistic ideas on that?
It's a very simple concept.
Jenny, is this yours? No? Yours is like this, though, isn't it? No, yours has an arm, doesn't it? Okay. Jenny is a part of a group that has built these. And one of the things that it has to do is shoot at least 15 feet. And you think that that's easy, but it's not. Because what you're also required to do is shoot it straight 15 feet.
Straight. Like it can't arc.
Well, no arc, but I'm talking about like you're gonna have to put a target and you're gonna have to try to get to that target.
Oh.
So it can't have this big hook or draw to it, okay?
Slice.
So this is one of the examples of a ping pong ball launcher that didn't really follow the guidelines of keeping something simple. But the problem you get into is building it probably wasn't too difficult. Where do you think the nightmare lies? Programming it. Okay? This is going to be one of those things too, based on your all's knowledge of programming. This is not going to be a joint effort between Mr. Ware and 11 groups of 2 or whatever we divide up into. We don't have time for that, do we? Because he's going to yell for help, and then he's going to yell for help, and then she's going to yell for help, and it's just not going to go there. So it is very beneficial for your groups of 2 or 3, whatever we do, to keep it as simple as possible. I would suggest, now if you want to go that route where a wheel fires it out like a baseball throwing machine, that's fine. Is that the simplest way to do it? No. Okay. The simplest way to do it is just hit it with something. Now you guys are at an advantage over last year's class. You can use the 3D printer to design something to help you strike the ball, you know, flush. But here's the other problem. You're going to have 8 or 9, 10, 11 groups in here wanting to print stuff. So that's going to require either print something before class starts or during the day or sometime other than this class period, okay? All right, so let's go through the PowerPoint and then we'll talk about more of the launch requirements, okay? Good to go? Any questions, yes?
Are we in our groups today?
Yes, we'll be in your groups today. Any other questions?
Is there an example of a preferred stippler?
I'll let Jenny get hers out here in a minute and show you. You know where it's at? Okay, I'll let her get out. All right, so we talked about the differences of these. One of your questions over here is what factors affect the launch? Okay, so think about a space shuttle launch. What factors affect that launch? The angle, payload, weather, thrust, Wind speed. Did you guys see in the news last night? It was interesting that we talked about this a little bit. There was a guy down in North Carolina that there was a train accident. This just happened yesterday or the day before. There was an accident with a train, and the train hit the support for the bridge and took the bridge out. So there was a gap of about 20 feet from one side of the bridge to the other, and about a 30 or 40 foot drop. Okay.
Sounds fun.
Okay. And he did the old, you guys would call it the Fast and Furious move, but for us old people, they call it the Dukes of Hazzard move. And he just floored him. And he made it.
idea.
He made it. And the investigators that went and looked at the wreck said if he'd have tried to stop, he never would have stopped. He would have gone over the 40-foot drop off onto the train crash. But the reason that he did good is he could accelerate the truck that he was driving at a greater rate than gravity was pulling him down. Does anybody remember that rate?
Wait, what?
Rate of acceleration.
Wait, let me ask this.
32 feet a second.
Driving across the bridge at the train.
The train was going under it. He was going over top.
So he was driving a vehicle.
Driving a vehicle over a bridge that a train went under.
Well, there's other vehicles that were on it with him.
No, it was a country bridge.
So he jumped the bridge.
He jumped.
That's awesome.
It's on the news. You can look it up.
Did that video of him jumping?
There's no video of him jumping.
That'd be awesome, though. Wouldn't it be awesome?
There's not
Watch
cameras
the
everywhere.
Give me the Dukes of Hazzard noise.
Okay.
Let's go watch the Dukes of Hazzard.
Huh?
It's a book there is.
Yeah, there is. So he could overcome the acceleration of gravity by accelerating greater than that rate itself. And somebody said, what is it? How many feet? 32 feet per second. Okay, so let's talk about this a little bit. Not much.
Because I was gonna say, how do you make it?
All right, so we talked about this a little bit. What's the major difference between velocity and speed?
Velocity deals with motion.
Velocity
Direction and speed.
is direction and
Yeah.
speed. Okay? So if we talk about the initial velocity of your ping pong ball, you're gonna give me back an answer that's probably in a speed, but I also need to go with direction. I was launching my ping pong ball north at 50 feet per second. Okay, that's an acceptable answer. If you just come to me and I say, well, tell me about your initial velocity, and you say 50 feet per second. Okay, did you miss the trash can because you fired it in the wrong direction? Okay, so I gotta know this. So we've got this acceleration is what we talked about. That's not the speed it's going. Okay, that's the rate in which it's increasing that speed. Or if it was deceleration, it would be going back, right? Any questions on that one? Nope. Gravity, you know what gravity is? It's a little harder on some of us than it is the rest of us. Gravitational acceleration is what we just talked about, negative 9.8 meters per second or negative 32 feet per second. All right. We talked about my pretty little slide. Did anybody get your phones out? Everybody get your phone out. Come on, quick. Oh, you got it. Terminal velocity, what is it?
100.
Find out what it is.
Of what?
I don't know. What is it?
Is it 160?
I don't know. I don't want guesses, I want answers.
Ask me what.
Trying to remember.
What is terminal velocity? What is the maximum speed at which you can fall?
Oh, I know that.
60 meters per second.
How many?
60 meters per second.
How many feet is that?
180.
It's a little over 180, isn't it? 100, is it about 196 somewhere in there? Something like that? Oh, here, let's go back 60 meters. Well, no, we'll go 180. So you can't fall any faster than 180 feet per second.
A meter's shorter than a yard, so it'd be less.
Meters like
Yeah,
3
it'd be
inches.
less.
A little bit less.
It'd be less, it'd be like
Longer.
179 or
A
179.
little bit less than a yard.
So around.
Actually, a meter is 3.28 feet, which is longer than a yard.
I don't think that's right. Because 100 meters in track is shorter than 100 yards on a football field.
All right, we'll pause for this. Go ahead. How many feet are in a meter?
3.
0.28.
just say that if he's ever seen the track,
Remember, yards, meters, multiplied by 0.91 square footers. Like it's-
I would put this on, right, would it? I would.
Yes.
No.
I'm pretty sure that's wrong. We'll look it up in a minute.
A meter is shorter than ours.
Okay. Human cannonball. All right, this is what we need to know for our human. We're not doing a human cannonball. We're doing a ping pong ball cannonball. Okay, here we go. Firing angle theta, which is your calculations that you will be doing, because we are going to be keeping launch speed the same. Initial velocity. Well, we're going to measure that. What you guys are going to do here in a little while, after you get all your pretty drawings and stuff done, is you're going to decide how you're going to launch it. And then once we get that built, I'm going to give you a ping pong ball, and we're going to put marks on the board back there, and we're going to videotape it, and we're going to see once you launch it how many feet it goes per second. We're going to do one of those little Mythbusters experiments. And every machine will have to do, so all the groups will have to come back and test their, yes, sir?
After we do the thing to see if we can hit the target, can we just see which one will shoot it farther?
Sure. Sounds like fun to me. Which one goes the furthest, which one goes the fastest, that's fine, yes.
Can we have an all-out ping pong war?
Like we did in engineering club?
Yes.
he wasn't here for it.
Oh, he wasn't here for that.
I
We might take
volunteered.
the launchers and have a ping pong ball war like we had in engineering club.
Like
Okay.
a pass, make it happen.
Okay, so let's go. So as you're accelerating, because of this, now, what is the power that sends this guy up in the air?
The cannon.
It's the cannon, right?
Yeah.
So is there any any power or energy that's accelerating him after he comes out of this? The minute that
Momentum.
he comes out,
It's just
he's
momentum.
losing, right? He's losing speed.
There's no
He's-
inertia to be considered energy though, that's like the kinetic energy that's pushing on inertia.
The initial,
Okay.
the initial power. So when he comes out, he's fired at 128 feet per second, and then he's going to slow down to a point, and then he's going to start falling at 32 feet per second. That's constant. It's never going to change. There's
It'll fall
always
back into the
gravitational acceleration or deceleration at 32 feet a second.
We shot out of it.
Unless we go to the moon,
It's just
nothing's going to change. Okay? In a perfect world with gravity off, you can shoot the cannon at any distance and hit a target. But we know that that's not the way it works. Okay? Here's the formula. If you need to write that down again, it should be in your notes if you need to highlight any part of that. The big thing that you guys are going to have to be critical of, now on the test that we take, you're going to have to know how to manipulate the formula in all the directions that I told you about. But for what you're concerned with, you're calculating firing angles because your gravity is a constant. Okay? Your distance will change based on the angle that you put in. So the main thing with your machines is that launch angle, right? Okay, so now let's talk about what you build. Okay.
It takes 4 meters to reach.
Always on her. I always on her. It doesn't matter what it is. I was just thinking.
Trent, you were the main one arguing about it.
Oh, no.
Point.
Yeah, you were.
Okay.
Whatever.
Here's how we're going to divide this up. Totally random. You ready? How many of you guys are born in January? One man team, no, I'm just kidding. How about February? Okay, you two are partners. Woo! Get your notebooks and head on over. Or head on over to the floor or whatever. Okay, how many of you guys were born in March? All born in March. April.
April was born in April.
April and April. All right, you two are partners. Go. May. Oh, now here we go. You two and you two. What year is March?
Yeah.
Yep. You two and you two.
I was born back in
June. 3 Junes. 3-man team.
I swear, I'm partners with you.
April.
July.
April. No, go ahead.
July.
July. I went backwards.
I was born in October.
July. You got 1 July. August. You two.
Uh-oh.
Yay, coming.
Here's when it gets down to business.
September.
Zeb! Yes! Save me a job.
I'm October.
Please.
3-man team.
Woo!
October.
We are always on the team together.
You're good.
You
October.
guys are born in the same month.
November.
Ranger and he is there.
Are you on a team yet? When is your birthday?
Yeah.
You two and you two. Now everybody's got a team. Wait, what? You two. Oh, and you two.
Hey, it's the first time you've done it. Oh.
Oh, was he trying to go all the way over the top?
Why you take my?
Did I bust him out? I busted him out.
Why you?
Did you get in trouble?
Then she moved me so that I was silent for the rest of the class.
Oh, you shut up.